Aaron does science.
Hello everybody and welcome back to another episode of Aaron Does Science. Now we've been off for a very long time and you may have been wondering what the hell has happened in all that time. Well, thing is, we have been making hundreds and hundreds of thousands of conferences trying to figure out the top marks to make us the best show of YouTube, and we thought of the best idea, the most original idea that has never been done before. Totally our idea. And it's a clapperboard.
Action. What?
Anyway, as a fun fact, the speed of light travels at approximately 300,000 kilometers a second.
Oh! Cut!
So, we are going to make some photosensitive paper and paint it with light, although it may not be as fast as the speed of light. So, first of all, we are going to create the light, and this time I have my own batteries. So now, I'm going to connect both of these wires to the crocodile lips of their corresponding colour. The black crocodile lip in wire is negatively charged, whereas the red one is positively charged. Now, I'm going to connect the black wire to this bent part of the LED. Then finally, I'm going to touch this, and it should light up. Now, just before we play with these chemicals, we are going to put on some gloves, as these can be harmful to our skin. To make our light sensitive material, we are going to have to use a mixture of these 4 chemicals. This yellow one is citric acid. This green one is ammonium iron 3 sulfate. This white one is ammonium carbonate. And to make us be able to see all this, we're going to have to use potassium hexacyanoferrate. That was hard to pronounce. We obtained our photosensitive mixture by combining the 3 components: iron 3 ions from the ammonium iron 3 sulfate solution, citric ions from the citric acid solution, and hexacyanoferrate ions from the potassium hexacyanoferrate 3 solution. When light hits the iron ions Fe3+ from the ammonium iron 3 citrate, it initiates a reaction in which Fe3+ gains a negative electron, reducing it to Fe2+. The product of this reaction is not yet visible, and that's where potassium hexacyanoferrate 3 comes into play. It doesn't stick to Fe3+, but once it meets Fe2+, it forms an insoluble, intensely coloured compound called Prussian blue. This is what we see when we look at the cyanotype image. Now we are going to paint the paper using these. Nowadays, this technique of drawing with light is mostly used by hobbyists to print photos or even decorate clothes. But in the second half of the 19th and early 20th centuries, it was commonly used to copy technical drawings. That's why architectural plans and technical drawings are often still called blueprints. Alright, now we are going to draw on our new paper using the light that we made earlier. Light is a form of energy that many substances can absorb. When we talk about the energy absorbed by a substance, we mainly mean that the electrons in the substance's atoms receive this energy. Therefore, electrons get excited by this power-up and perform something that we can call an electron jump. In most cases, such a jump ends with a simple emission of the excess energy back into the surrounding area in the form of heat. This is why, for example, dark-colored objects, which absorb a lot of light, heat up quickly in the sunlight. But there is another way to release that energy. The powered-up electrons can jump from one atom to another, resulting in chemical changes. In other words, the light itself initiates the chemical reaction. Processes that are powered chemically or influenced by light are known as photochemical reactions. One of the most well-known examples of such a reaction is photosynthesis in plants, one of the building blocks to all of organic life on Earth. The light from the LED initiates a series of reactions. Iron 3 ions interact with the citrate ions. They receive one electron and are reduced, transforming into iron 2, while citrate ions are oxidized. The Fe2 plus ions react with the hexacyanoferrite ions, yielding the dark blue precipitate, iron 3 hexacyanoferrite 2, also known as Prussian blue. Alright, so we have now rinsed this with clean water and you can see the dark spots. Hopefully you can see my smiley face on here that I have drawn. And that's pretty much about it for all we have done. I hope you enjoyed and I hope you found it very, very interesting. Maybe at one point you could even try this yourself if you get the materials. Well, I hope you have a lovely day or night and I shall see you all in another episode. Bye bye!
Arrow. D. Science.